Hello dear students, welcome to DAV Moyle Public School. I hope you are doing great with the chapter of light. In today's video, we will study about image formation in terms of concave mirror. Earlier, we have studied some rules regarding the situation of how to manage or how to construct image in terms of mirror. So that rule we will apply in order to obtain image. What are the cases we will study over here? So image formation by a concave mirror. There are six cases. The six cases we will study separately and we will simply focus on concave mirror first. Now, when the object is at infinity, so since we are studying concave mirror, so I have drawn a concave mirror, principal axis, a pole is there, center of curvature, certain things are indicated over here. This is pole, this is center of curvature and a principal axis. Now, when the object is at infinity. Now, what do I mean by the statement or the word infinity? Infinity is a point, is an imagination point or hypothetical case wherein you have to consider a range or a point beyond a measurable distance. So that point here, a ray of light is coming from any n direction. That n direction I do not know from where it is coming. So that it is coming from, so I'm considering that light ray is coming from an infinite distance. So whenever ray of light is parallel to principal axis, earlier we have studied about rules. So what we have to apply the same rule in order to obtain image. So certain things are applicable in order to obtain an image. I have to consider minimum two rays. So one ray won't do. So I have to consider two rays. So one first rays I have taken the like whenever incident light ray is parallel to principal axis, we know whenever things happen, the reflected light ray would always and always pass through focus. So same thing, the reflected light ray is passing through focus. So in order to get a desired image, I need to have two rays of light. This I already took. So image is forming exactly at the focus. So this is the focus. Now again I have to take another ray of light. This ray of light is again parallel to principal axis. So the reflected ray again would be passing through focus. So now since I got two rays, the image would be obtained exactly at the focus. Now again, this is the incident light ray which is parallel to principal axis. This yellow line, incident light ray, this light ray is coming from an infinite distance. This is an infinite distance. It hits the surface, but this incident light ray is parallel to principal axis. So at the point of incidence, the reflected light ray would pass through focus. Another ray, I'm taking an example. Another ray, this is a parallel ray. This is another incident light ray. It is parallel to principal axis. At the point of incidence, at the reflecting surface, the reflected light ray would pass through focus. Now, which the image would be obtained exactly at focus over here. Now, so this is this red line is a normal, which is happening in case of this angle created over here, angle of incidence and angle of reflection over here. This is the normal, this is angle of incidence and angle of reflection. Again, we have studied in rules whenever this normal will always and always pass through center of curvature. So as you can see, this is passing through, this is the exact center of curvature. This line is passing through center of curvature. Again, incident light ray and reflected light ray, this line, this normal is passing through focus. As you can see, this reflected ray, it is passing exactly at focus. This reflected light ray is exactly passing through focus, which is residing exactly over here. Now, as you can see, where was the object located? The object was located at infinite distance. The image was obtained. The image was obtained exactly at focus. This was the focus. So image is exactly at the focus. This image is always real and inverted. Earlier we have studied this image is real and inverted. Inverted means upside down. Real means it can be obtained on a screen and it can be even felt. And it is always and always a point size image. This is the point. Here the image is residing, it is real and inverted, and it is a point size image. So what does first rule says? Whenever the object is at infinity, we have to consider two parallel rays. This one was the first one, this one was the second one. The reflected light ray would pass through focus. So the image would be obtaining over here. The image is real and inverted, and it is a point size image over here. Now let us discuss case number 2. Now, when the object is behind the center of curvature. Now, again, this is a concave mirror, principal axis, center of curvature, and a pole. Now, object is behind the center of curvature. Center of curvature is located over here. So the object is behind the center of curvature. This arrow is an object. This arrow is an object. It is behind the center of curvature. Now, earlier the object was at certain infinite distance. The image was obtained exactly at focus, and the image was real, inverted, and point size. Now the object has come little forward, but it is behind center of curvature. So the object is located over here. In short, you can also say that object lies in between infinite distance and center of curvature. Object in between infinity and center of curvature. Object is placed at infinity and center of curvature. Again, I have to consider two rays. This ray is again a parallel ray. This is incident light ray, and this is incident light ray, and this is principal axis. So incident light ray is parallel to principal axis. So the reflected light ray would pass through focus. So this is the reflected light ray. It will always pass to one particular point. That particular point is focus. So this is the focus. So again, I have to take another ray since the object this object was over here. So I have to take another ray of light. This was the second ray of light. Now, as per the second rule, this is the incident light ray. Now, whenever incident light ray passes through the focus, the reflected light ray would be parallel to principal axis. We have studied previously. This is the incident light ray. Earlier it was parallel to principal axis, but this time this is the incident light ray, but it is passing through the focus. Passing through the focus, the reflected light ray would be parallel to principal axis. So the reflected light ray is parallel to principal axis over here. As you can see, this is a reflected light ray, green line. It is parallel to principal axis. So at the point of intersection of both the reflected light rays, this was the reflected light ray of the first situation, and this was the second one. Both the point of incidence is residing over here. So the image at the point of intersection, the image would be formed at the point of intersection between both the reflected light rays. At the point of incidence, at the point of intersection was over here. So the image has formed over here. As you can see, this image and this image are of two different nature. Here the arrow is in upward direction, here the arrow is in downward direction. Here the object is relatively a larger one object, here it is small. So there is a certain discrimination happening between object and image. This thing happens because the object is placed between infinite distance and center of curvature. So whenever object is placed between infinite distance and center of curvature, the image would be obtained between center of curvature and focus. This, as you can see, the image is lying between center of curvature and focus. This is the image. So the image is formed between center of curvature and focus. It is inverted. Here it is, as you can see, this arrow is upside down, which means it is inverted image. Though it is real image, but it is inverted image. And as you can see, it is smaller than the object. This is the smaller than the object. As you can see, this image is smaller than the object. So again, a normal I'm drawing between incident light ray and reflected light ray. It is passing through focus. So what we got from this case number 1, whenever object is placed between infinite distance and center of curvature, the image will always and always be obtained between focus and center of curvature. The nature of image would be real and inverted, and it is always smaller than the object. Now let us see the third case. Now, when the object is exactly at the center of curvature, what will happen? Again, I'm taking an example of concave mirror. Principal axis is there, center of curvature, and a pole. Now, when the object is exactly at the center of curvature. Now, this is the center of curvature. When the object is at exactly center of curvature, this center of curvature should be over here, and this is also miss animation. This center of curvature should be over here. When the object is at the center of curvature, what will happen? Where will the image would be obtaining? Let's see. Now again I have to take two rays. First rays is parallel to the principal axis. This was the first ray. It is parallel to the principal axis, and as per the rule, it will always and always pass through focus. The reflected light ray would always and always pass through focus. And again I am taking an example, another light ray, that is which is passing through focus. Now this is the incident light ray, it is passing through focus. The reflected light ray would be, this is the reflected light ray, would be parallel to principal axis. This rules we have already studied. Now at the point of intersection between both the reflected light rays, it is happening exactly over here. So the image would be obtained exactly over here. But it is inverted image. So the image is obtained exactly at C. Exactly at C, the image is obtained. So again, we are drawing normal at both this incident ray and reflected ray. Again over here, incident ray and reflected ray, we are drawing normal. So that normal will always and always pass through center of curvature. So what we have obtained from this case, whenever the object is exactly at the center of curvature, the image would always and always be obtained at center of curvature. But it is, though the image is real, but image is always and always inverted, and it is of same size as that of the object. As you can see, the object size and the image size are same, but the image is inverted. This thing happens whenever the object is placed at center of curvature over here. Now let us see the fourth case. Now, when the object is between the center of curvature and the focus. Again, concave mirror, principal axis, center of curvature and a pole, focus. Now, when the object is between center of curvature and focus, now the object is residing in between center of curvature and focus. So the object is located between C and F. Again, I have to take two rays, minimum two rays, then only image would be obtained. So first ray I am taking, first incident ray, which is parallel to principal axis. It would pass through focus. So this is green light, it is passing through focus. Again, another incident ray, it is passing through focus. It is now the reflected light ray would be parallel to focus, parallel to principal axis rather. First one, this is incident light ray, it is passing through focus, and second case, the incident light ray is passing from focus. The reflected light ray would be parallel to principal axis. Don't get confused. First one, the incident light ray is, whenever incident light ray is parallel to principal axis, the reflected light ray would pass through focus. Now, second ray, when incident light ray is passing through focus, the reflected light ray would be parallel to principal axis. Now, at the point of intersection of both the reflected light rays is happening over here. So the image would be obtained at this particular point. The image would be obtained over here. And as you can see, the object is over here and image is obtained over here. So the image would be obtained between infinite distance and center of curvature. As you can see, the image is larger than the object size, as you can see, object size and the image size. again a normal. In this incident light ray and reflected light ray, a normal is drawn, which is meeting at center of curvature. So what we have obtained from this case number 4, whenever the object is at center of curvature and focus, the image would be obtained between center of curvature and infinite distance. So the image is obtained over here. It is always real and inverted, and it is larger than the object. Now let us discuss case number 5th, which says that when the object is exactly at the focus. Concave mirror is there, principal axis, pole, and the object is located exactly at F. As you can see, this arrow is an object. Now the object is placed exactly at F. Again, I have to take two rays in order to get an image. So first rays I am taking, this is an incident ray which is parallel to principal axis, and as per the rules, it will pass through focus. This is a reflected light ray. It is passing through focus. Now another, I have to take another ray. This is blue. This is yellow line. Another incident ray of light. Now will pass through pole obliquely, and as per the rule, whenever incident light ray touches the pole, the reflected light ray would travel the symmetrical path obeying angle of incidence and angle of reflection. So this angle would be equal. So this is incident light ray and this is reflected light ray. As you can see, the image would be obtained at infinity. As you can see, this ray of light is going beyond in some range. That range is located at infinite distance, and the image obtained would be relatively very larger than the object. So the image is obtained at infinity. As you can see, both the rays, reflected light rays, would meet at and some infinite distance. So this we are drawing normal over this incident ray and reflected light ray, as well as over here. Both will pass the center of curvature. So this we think these are the conditions. Whenever the object is located at focus, the image would be obtained at an infinite distance. The image would be always real and inverted, and it is infinitely large. It is very infinitely larger than the object. Now, last case, that is when the object is placed between focus and the pole. Now, this is again a concave mirror, principal axis, pole, focus, and center of curvature. Now, as you can see over here, the object is placed between pole and focus, in between this range, between pole and focus. This blue one is an arrow, which is an object. Again, I have to take two rays. First rays is this. This is parallel to principal axis. It will pass through focus. This green light is a reflected light ray. It is passing through focus. Another ray I have to take, this one, as incident ray. Again, it is passing through pole. Again, it would be reflected over here. As you can see, this light ray, this reflected light ray is of diverging nature, and both the reflected rays will never meet. Even at an infinite distance, both the rays will never meet. So I have to trace this path backward. This green light, reflected light ray path, I have to trace backward. So this path, this reflected light ray, I'm tracing this path backward in this direction. With the similar things, I'm tracing this reflected light ray path backward in this direction. Now the traced path of the reflected light rays is intersecting over here. So the image would be obtained at the intersection path of this traced path of reflected light ray. So the image is obtained at over here. So as you can see, object is over here and image is obtained on the other side of lens. As you can see, other side of the lens, and both the image are erect. As you can see, this arrow pointing and this arrow pointing are both are in same direction, but the difference arises that this object is very small and this image is relatively very large. So whenever an object is placed between this red one is a normal which is happening between these two rays, whereas this again dotted lines is a normal which is happening between this incident ray and reflected light ray. So whenever object is placed between focus and a pole, the image would be virtual. It cannot be obtained on a screen and it is obtained behind the mirror. And as you can see, this blue arrow is erect. Hence, the nature of image is always virtual and erect. The image position is behind the mirror and size of the image is magnified. As you can see, this object is very small and it is a magnified image of this object. I hope you have understood the formation of image formation in terms of concave mirror. Thank you and have a nice day.